Okay, done. Uh, so the next one is suffix sums. Suffix sums are basically like prefix sums. They start from the last element. So the last element is n minus 1, and we are going to be iterating till 0. So n minus 1 till 0 instead of 0 to n minus 1. This is just the reverse of prefix sums, but you start from, because you start from the last element and keep the sum. For example, if you say you have 5, 4, 3, 2, 1, then the sum will start from 1, and then you'll have uh, this will be 1, and this will be 3, 6, and 10 and 15. So this is prefix sums. I mean suffix sums, sorry. So this is suffix sums, and we are going to be testing your understanding now. Check your understanding for prefix sums. How would you change the implementation to prefix GCD? So what's the point? We'll actually see. Why not just prefix sum? You'll actually see in a future problem. I'm going to be discussing a problem right now, and that will include suffix sums. So prefix of 0 equal to array of 0, and this is the basic implementation. How would you change the implementation to prefix GCD? And how would you implement suffix sums? If you just provide your answer in the comments. So think about how you added the elements. So instead of adding the elements, how would you change it to GCD? So we just did prefix of I equal to prefix of I minus 1 plus AI, and you just take the GCD of the two elements instead of adding it. So that's the answer for problem 1. Instead of prefix of I equal to prefix of I minus 1 plus AI, we are going to be taking the GCD of GCD of I plus 1 equal to GCD of I and element I, exactly. So instead of adding it, we are going to be taking the GCD. So that's basically how we would implement prefix GCD. How do you implement suffix sums? So suffix sums is actually also pretty simple. You just, as I said, you just have to reverse the implementation of prefix sums, but you have to change a little bit of things. Yes, for I equal to n minus 2 to 0, prefix of n minus 1 equal to array of n minus 1. Actually, yeah, you just have to rename prefix to suffix. That's it. Just by running reverse the loop. No, that's actually not how it works. It's a bit different. It's a little bit different, but you are close. Yeah, Saurabh and Keshav got it. So now this is the solution. Prefix of 0 equal to array of 0, and prefix of I equal to GCD of prefix of I minus 1 and AI. So instead of adding it, we just inserted GCD there. And suffix of n minus 1 equal to array of n minus 1, and from n minus 2 to 0, notice that we are not starting from 1 for the same reasons. N minus 1 plus 1 will be equal to n, which is out of bounds. So n minus 2 to 0, suffix of I equal to suffix of I plus 1 plus AI. So this is how you would implement suffix sums. Did everyone get it? If you didn't, please let me know. Okay, I guess everyone got it. So let me move on. So let's discuss a problem right now. We are going to be discussing the quiz problem. So there's six students standing next to each other in a line. So this can be 6 or 8 or 15 actually. So there are n students standing in a line, standing next to each other in a line, and the students have skill levels of this, and this. This is actually a sub problems. So there are three problems with each with different solutions, but the problem statement is the same. So only the array is changing. So a group consists of 2, 3, and 5 consecutive students, 2 or 3 or 5, depending on the problem. So this can be denoted by K, and the array can be denoted by A. And then select two groups A comma B such that the absolute difference of sum of A minus sum of B is maximum. where sum of A denotes the sum of the skill levels of the students in group A. For example, if we select this as this, for example, there are 5 consecutive students, so this could possibly be a group. And if we take the sum of all the elements, and this could also be a group. So these two can be two groups, and we are going to be taking the sum of this and the sum of this, and we are going to be minusing them. So sum of A minus sum of B. So this is what the problem statement asks. Simon says sum of A equal to max window, sum of B equal to min window. Actually, I guess you are trying to say that, yeah. Is this ABS of A minus B? Yes. So vertical line denotes an ABS. So absolute value. If it's negative, it becomes positive. But if it's positive, it still needs to be positive. Do both groups need to be of equal number? Yeah, actually, a group consists of k elements. A group consists of 2 or 3 or 5 elements. So depending on the problem statement. So if it's problem 4, then it's 2. If it's problem 5, then 3. And if it's problem 6, then it's 5. So it's fixed number. We can denote it as k, and a group consists of k consecutive elements. So a student cannot be in both groups. So this is an important point. So you can't just have A equal to this and B equal to this. So this will be intersecting with this elements. So a student cannot be in both groups. So now we are going to be discussing the solution. So denote the array by A and the size of each group by K. Take the sum of every window of K in A. So let's take this as a small example. So 5 minus 4, 3. 5 minus 4, 3, and 8 minus 12 and 0. 8 minus 12 and 0. Do both groups have to be, can A and B have different number of students? No, A and B has to be having exactly K number of elements. So the groups have K elements in them. So, and the group consists of 2 or 3 or 5. These are fixed depending on the problem statement. So, this consists of K consecutive elements. So, select two groups A, comma B. So, A and B have to have K elements each. So, they cannot have different number of elements. So, now for each index, you have 3 options. So, you can either take, so first of all, create the window sum. So this is 1. So take the sum of every 2 consecutive elements. You can use sliding window for this, if you would prefer it. So this is 1, minus 1, 11, minus 4, and minus 12. So we now have these numbers. So for each I, you have 3 options. Take the minimum till I minus the maximum from I plus k. So notice how, so this is window 1. Window 1 is this index, and let me use a different colors. This is window 1, and this is window 2, and this is window 3. So notice how, no, window 1 and window 3 are not colliding with each other. So there are no intersections. Till window 2, 1 and 2 had an intersection, but after window 2, there are no intersections. So basically, array of the sliding window will denote it by S. Sliding window of I will never intersect with sliding window of I plus K. So these two will have no intersections. This is because we are jumping K windows. So this is one window, this is two window, and the third window we are going to be moving away from this window. So these two have no common elements. This is an intersection sign. So these two will not have any intersections. Now you can either, say you take the sum of absolute value of A minus absolute value of B. Instead of the absolute value, we'll just denote this as such that A has the maximum value and B has the minimum value. So we'll just say that sum of A is greater than sum of B. So this will make things a bit more simpler. And then you take the minimum till I minus the maximum from I plus k. So basically I'm just saying that sum of b has, so we are starting from I plus k because we don't want any students to intersect. So we are going to be starting from I plus k. So if you have a window for like this for example, we are going to be starting from I plus k and then moving on. And we take the maximum group. So I mean we take the maximum group and minus it to the minimum group. So this will, have the largest value. This might have the largest value. So for example, say there was -1, -2, and 3 and 4. Can we take max of a minus b or minus a minus b? No, that's actually not how it works. -1, -2, and 3 and 4. So taking these two, so sum of b will be equal to 3, 4. So the maximum might be 3, 4. Actually, it may reverse the order, so it's a bit simpler to understand. 3, 4, and -1 and -2. So minimum till I. So the minimum till I is equal to 3, 4, and the maximum from I plus k is -1, -2. So -1, -2, and this minus the maximum. This is 7. So -1, -2, -7. This is -3, -7, and if we take the absolute value, we get 10. So this is one way you could take the sum of two categories. So this might have the maximum answer, or you could do the opposite. Instead of taking the minimum till this index, we will take the maximum till this index and the minimum from this index. So basically we are just, in this case we denoted b to be the maximum and a to be the minimum. So b minus a. So we are taking the sum of b minus sum of a, and instead of doing that, we are going to just be doing a minus b. So in this case, this will be the maximum till I. So we assigned, we assume that a has a maximum value. So maximum from I plus k will have, oh sorry, I select the highlight. So this will be b and this will be a, and the maximum from I plus k. Actually, I'm messing up. Sorry. A will have the maximum value and B will have the minimum value. So we are going to be ignoring the ABS. So if we can ignore the ABS if we take the maximum minus the minimum. So that will basically remove the ABS. So maximum minus the minimum. We still need the ABS though. In case both of them are negative, we need the ABS. So A minus B. So this is maximum and this is minimum. So we are going to be taking the max from I plus k and min till I. Or we are going to do the opposite. We are going to take the max till I and min from I plus k. So we are going to do A minus B. And then there's another another way you can do this. So you can take the minimum till I minus the minimum from I plus k. So in case both of them are negative, for example, so say both of them have the same value, maximum and minimum have the same value of -12 or something like that, and this side also has -12. So instead of taking the maximum, we can take the minimum so that the final result will be as small as possible. So since we are minusing the values, we are going to remove, delete the maximum and insert minimum in there. So this will be -24. So this might also be greater. Could you please show the previous slide again? Okay, sure. So this is the slide. So the students have skill levels of some value, some array, and a group consists of k elements. So this depends on the problem. So problem 4 is 2, and problem 5 is 3, and problem 6 is 5. So we can denote this as k. And again, a student cannot be in both groups, so we are going to be starting from I plus k. Please remember that. So you might wonder why we are not taking the max of max till I minus the min till I plus k. So instead of, why are we taking the max, both sides max? So max minus max will never have a better value than max minus minimum. So if we take the minimum, we could potentially increase the value, but taking the maximum will always reduce the value more. So in this case, since the order does not matter in an ABS, so we are going to be taking, we can just reverse the order of the two elements. So will never be better. So taking both sides maximum will never be better. In 4 and 5, we can take max and min window as they have no intersection. Yes, you can do that. But in problem 6, you can't do that because the maximum and minimum have an intersection. So it was designed to be that way actually. So the answer is the maximum of all the possibilities. So you can take minimum minus maximum, minimum till I minus maximum from I plus k, or maximum till I and minimum from I plus k, or both minimum. So did everyone get this problem? Okay, please react with thumbs up if you did, and please react with confused emoji if you didn't. Oh, can you please explain what you didn't understand? So you didn't, which part did you not understand? So what was the answer to the question? It's actually I don't remember right now. I guess it's, yeah, 11 minus 12. So that's 23. So we are taking the maximum value and the minimum sum. So these two don't intersect. And for problem 5, I think, yeah, I think this minus this was the solution. So 4 minus 2 plus 7. So this is 4 minus 2 is 2, and 9 minus the 33 plus 6 minus 20 minus negative 27, which is positive 27. So 9 plus 27 was the answer, 36. So for problem 2 it was 36, and for problem 3 I actually don't remember. So you can work it out. So the little bit background noise, actually, yeah, there are crackers in the background. So couldn't you do negative 12 minus 4 minus 6 and add 8 and 5 to get 13, and then do negative 16 minus 13 to get 29? Sorry, Steve Vishnu, I didn't get you actually. Couldn't you do negative 12 minus 4? Oh, you have to select consecutive elements. You can't take, elements from random places. You have to select k consecutive elements. Okay. So shall we move on to the next problem? Actually, if you read about EXA, I'll tell you in Discord. Actually, I'll tell you in Discord. Can you please explain how prefixum work for EXA? I'll tell you in Discord. So problem 7. So there are 10 children who want to buy candies. The children have 15, 5, 7, 13 and so on rupees respectively. And you can manufacture any amount of candies, but you have to sell them for exactly k rupees. A child will buy a candy if they have at least k rupees. They'll buy at most one candy. So basically, children have a budget. So, and they'll buy at most one candy, and you can manufacture any amount of candies, but you have to sell them for exactly k rupees. This problem is actually very similar to, this is the same problem as ZCO smartphones. So I just wanted to show how an ZCO problem or ZAO problem could be used. So you can manufacture any amount of candies. So now, which case should you select such that will fetch you the maximum revenue? So now, notice that the most optimal case, so the budget will always be inside this array. So why will that be the case? So let's say we have some budgets like 2, 6 and 7, and you're selling it for 2 rupees. Then if you sell it for 2 rupees, you get 6 revenue. And if you sell it for 6 rupees, you get 12 revenue. But if you sell it for 4, it will never be the maximum, because you can always change it to 6. So changing it to 6 will, the same number of people will buy the candies, but you will have more revenue. So the answer is always inside this array. So the answer never exits this array. If you set something for 4, something like 4 for example, it will just get 8. So the maximum, the most optimal k is always inside this array. So the provided array. Now selecting k, so sort the array first. So first of all, we sort the array. So the sorted array is the following, and take the number of children who will buy for that price and multiply it by the price. So basically, now how many children will buy for 1 rupee? So there are 1, 2, 3. So there are there are 10 children, and the 10 children will buy, say we set the revenue, we set the cost as 1 rupee, then 1 times 10, the revenue you get is 1 times 10. So 10 children will buy for 1 rupee. And then if you set it as 5 children will buy for 9 rupees. And if you set it as 6, you get 6 children will buy for 8 rupees, and so on. And the maximum is actually 11 children buying for 5 rupees. So this is the maximum. The maximum revenue is 55. There was actually a mistake in the problem set. So in the official quiz, there was a little mistake. It was my fault. I accidentally set the answer as 55. So I asked for this k value, which k should you select, but I accidentally provided the revenue. Sorry for that. And this is the problem. This is the answer. This is pretty simple. So this is way more simpler than the last problem. Did you guys get it? If you didn't, please react with the confusion message. I guess everyone got it then. So let me move on. Problem set 7, answer 7. So implementation. So the implementation will set k equal to 0. So k equal to 0 will fetch you 0 revenue. So that will be the maximum for now. So we are going to be updating that max. So for I equal to 0 to n minus 1, if the maximum is less than ai times n minus I. So n minus I, notice how n minus I is the number of elements left. Number of people who will buy that. So 1, 2, 3, 4 for example. And if you take I equal to 1, so if you set the price as 1 rupee, then it will be a of I times n minus I. So n minus I is equal to I equal to 0. So 4 minus 0. So this is equal to 4. So 4 people will buy the candies. So, and if we multiply the candies, number of people who buy the candies times the price of the candies, so this will take the maximum of this and this. So if the maximum is less than the current revenue, we'll get by setting it as k. So if you set I of I equal to k, then we will get this revenue. So if this is greater, then k equal to ai. If this is not greater, then you just continue. And if this is greater, you set k equal to ai. So since we want the final k, we'll set k equal to ai, and max equal to ai times n minus I. Vihang says I have another solution which I think is rather inefficient. Let a be the sorted array of all the budgets. Then for each I till length a, we calculate a of I minus 1 times length of let's say and find the max of these elements. Actually, this is the same as my solution. This is the exact same as my solution, except you don't need ai minus 1. So since ai is the profit you get, ai minus 1 is not necessary. You don't have to have that minus 1. Yeah, and we take the max of all these elements. So this is the implementation. So did everyone get that? Oh, actually, I did sort. I did sort because, oh, I forgot to mention that. But if you don't sort it, you won't get the number of children who buy that candy. So I have to sort the array. I'm really sorry about that. If you don't sort the array, uh, basically, so n minus I, for example, could be wrong. So for example, if you set 100, start with 100 and then there's 2 and 3, you'll accidentally say that when I equal to 0, n minus I people will buy it. So 3 people will buy it. But this is wrong because the budget of 2 children is 2 and 3. So you have to sort the array. And I didn't add that. So first of all, you need to sort that. And then you need to do the following. So, okay. So shall I move on? If you didn't understand anything, please react with the confused emoji. Can you take max equal to max of k comma max? The problem is we have to update k as well, so this won't work. You can't just take the max of these two elements. Okay, so let me move on. Problem set question 8. So we have this array, and how many non-empty subsegments are there in the above array such that if you reverse it, the entire array will be sorted in a non-decreasing manner. So this is just so non-empty subsegment means that taking 4 consecutive elements, for example, is a subsegment. So the subsegment has consecutive elements only. So it will never have elements like 1, 6, and 8. So consecutive subsegments mean there are only consecutive elements. So and they have to be non-empty. So you can't just have an empty subsegment. So now you have to find the number of subarrays or subsegments such that if you reverse it, the entire array is still sorted. So if A is still sorted. So non-decreasing means decreasing means 5, 4, 3, 2, 1, and non-decreasing means it's not decreasing. So increasing would mean 1, 2, 3, and so on. But the problem is increasing doesn't contain same elements. So this 1 and 1 can't be increasing because 1 is equal to 1. So this is not increasing. So we denote it as non-decreasing. Non-decreasing means it's not decreasing. It might have the same elements though. It can have the same elements in the same order. So notice how the array is still sorted. So the array is already sorted. So you don't have to change anything in this array. So how many subsegments are you there such that if you reverse it, so this array is already sorted. And if you select any element, any subarray such that it has two elements, two distinct elements, that means that the order will be removed. So you'll basically unsort the array. Since the array is sorted, we shouldn't change the order of any elements because we'll unsort the array. But notice how reversing a subsegment with the same value. So for example, reversing 666 doesn't change anything. But it does create one reversal. So there's one way to reverse this subarray, at least one way to reverse this subarray without changing the order of the elements. So notice that reversing subsegments with a single distinct element will not change the array. So if it has the same element, then it will not change the array. So the solution is the number of such consecutive subsegments. So now how do you compute the number of subsegments, number of the subsegments? So 1 and 1, for example, have 3. So it is 1, 1, and 2. So it can be 1, the first one, or the second one, or 1 comma 1. So it can be this, this, or this. So notice how there are two ones. So that's because of the first one and the second one. So now, how would you calculate the number of these subarrays? So 1 comma 1 is one subarray, and then 1 is another subarray. So and another one is also a subarray. So if you take the elements, number of elements with one, if you take the number of values such that it has exactly one, its size is exactly 1, you have n elements. So let's denote the size of the longest consecutive value by k, for example. So k equal to 4 for 4 when you select 3. So could you explain how it would work if the array had distinct elements? So if the array had distinct elements, I will actually say it right now. We'll say it right now. And 3, 3, 3, 3, and k equal to 4 for when you select 3. So now how many values, how many subarrays of size 1 are there, such that it has only one element, one distinct element, and that's equal to 3. So there are 4 threes. You can select 4 types of threes. So this has 4 values, because the first 3, second 3, third 3, and fourth 3, and then it has 3 comma 3 for 3 times. I mean, it's 3 comma 3, and the first window, second window, and the third window. That's another value. And then you can select the first window and the second window, and then it's 1, just a whole window. So basically, so this is repeated for 3 times, this is repeated for 4 times, and then the next one will be repeated for 2 times, and this will be repeated for 1 time. So this is just n into n plus 1 by 2. So this is the sum of the first n elements. So when k equal to 4, the number of subarrays such that reversing it will give you, will still not change the order, is k into k plus 1 divided by 2. So there are these number of values. So now you just have to calculate it for each consecutive subsegment. But say a subsegment has only one value. So I'm answering the question Sumant asked. So if a subsegment contained exactly one value, then it will just be 1. So it won't change anything. So k into k plus 1 by 2 will be 1 into 1 plus 1 by 2. That is 1 by 2, 1 times 2 by 2, which will just be 1. Now k into k plus 1 by 2. So you just add 2 into 2 plus 1 by 2, and 3 into 3 plus 1 by 2, and 4 into 4 plus 1 by 2, because we are taking the size, and then 3, and then 2. So you add 3, so this will give you 3, and then you add 4 into 4 plus 1 by 2 is equal to 10, and then this is equal to 6, and this is equal to 3. So we are ignoring this right now. So now you add all of these elements, and this is 16 plus 6 is 22. So there are 22 ways you can reverse these subsegments such that it will be in a non-decreasing manner. So did everyone get this problem? If you didn't, please react with the confused emoji. And if you did, please react with thumbs up. So I'll be answering the questions in the questions tab. What is a prefix? How can it be defined as? So prefix is the first starting elements of a value. For example, if you have A, B, C, D, then the prefixes of A, B, C, D is A, AB, and ABC, and so on. So this is what prefixes means. So now, I'm not sure why this is happening. So you could tell Unacademy staff about this. So I'll be moving on right now, and to problem 9. So this is the hardest problem of the set, and it requires sliding windows and prefix sums. If you want, you can use prefix max, or if you don't, you don't have to. So, but using prefix max will be better. So f of k, if you select f is a function, and if you insert k into that function, it will give you the sum of every k consecutive elements in the above array. So so for example, if you select k equal to 3, then it will be 5 plus minus 7 plus 4 plus minus 7 plus 4 plus 7, and so on. We will take the sum of each window and add it all up. So that's what that's what f of k does. So what value of k would yield the maximum result? In case of multiple answers with the maximum value, enter the one with the largest k. What's prefix max? Prefix max is just prefix sums but instead of adding it, you just replace it with max. So the same as the GCD one. So instead of doing GCD of AI comma AJ, sorry, a prefix of I minus 1 and I array of I. Instead of doing this, we just take the max. Instead of, we are just going to replace GCD by max. So that's prefix max. It will be easy if you use programming. Yes, Abhinav, but the problem is there's no programming in UZIA. So how would you approach this problem? So you could also brute force it. Aryan right now brute forced it, but there's another, a bit more elegant solution. So let's take an example array. So if we take, we'll use characters to not avoid confusion. So A, B, C, D, E, F, G. So when k equal to 1, it will be A, B, the windows will be A, B, C, D, E, F, G, and then A, B, B, C, C, D, and so on, and A, B, C, and so on. And it will happen till k equal to 7, in which case this will be the entire array. So if you take the count of the elements in each of these values, so if you count the number of A's, it will be 1. So in each of these, the number of A's in this entire thing is exactly 1. The number of A's is exactly 1, and that's true for every other value. And the number of B is equal to 1 in the first array. So in the first array, there's just one B, but in the second array, till the last minus first array, it will be 2. So there are 2 B's. So in each of them there are 2 B's, except for the last one, in which case there's also exactly 1. And in the third one, if you count the number of C's, so this number of C's is 1, and then it's 2, and then it's 3, and then it stays as 3. So it doesn't change after that. And then k equal to 4. For D, it will be 1, 2, 3, 4, 3, 2, 1. So D is equal to 1, and then D is equal to 2, D is equal to 3, D is in all of these arrays, so D is equal to 4. And then it's again reversing to 3, and then to 2, and then to 1. So what was the problem? So the problem was f of k equal to the sum of every k consecutive elements in the above array. So for example, k equal to 2 will be 5 plus minus 7, 7 plus 5 plus negative 7 plus we are going to be extending the class actually. It will be till 6:30. I mean 7:30, sorry. Okay, so now this is 5 plus minus 7, and then plus minus 7 plus 4, and then so on for each index. So for each of the windows, you will take the sum of the window and add it to the total sum. So this is what the problem statement asks. And for k equal to let's take every other example. So now if you probably notice a pattern. So the pattern is A is always equal to 1, and B is 1 for the last two elements, and everything else is 2, and C is the same for first two, first and the last, and then the second and the second last are 2, and then everything else is 3, and D is 1, 2, 3, 4, 3, 2, 1, and so on. So notice how the array is reversing. So after this and the last one are the same. The second one and the second to last one are the same, and so on. So this is actually happening because k equal to 1 and k equal to 7, k equal to 2 and k equal to 6, etc. have the same count. The size of the window increases. So as the size of the window increases beyond one point, this number of windows decrease. So since the number of windows decrease, the total count will also decrease with the number of sums. The number of windows. So did everyone get observation 1? So the size of the windows increase, which reduces the number of windows. So the count of the windows also decrease. So for example, if you say you have 1, 2, 3, if you take the every single element, you get 1, 2, and 3. If you take every two indices, then you get 1, 2 and 2, 3. Notice how 2 is repeated twice, and then it decreases again. So after 3 it decreases. So after the middle point, so you can call this a middle point, it begins to, it's like a mountain, it goes up and then it comes down in the exact same manner. So, and then it will be 1 comma 2 comma 3 again. So this is what the problem with the first observation is. Did everyone get the first observation? So since we need the maximum value of k, so the maximum starts from 4. So notice how 1, 2, 3, 4 and 4, 5, 6, 7 are the same thing. So we are just going to be iterating the last n by 2 elements. So we don't even need this. We'll just be iterating through the last elements because this and the first values are the same. So we are going to iterate from seal 7 by 2 is 3.5. And we are going to be sealing 3.5, which is equal to 4. So we are going to start from 4 and end at 7. So this will always have the maximum value. If there's a maximum value, then this will always have the maximum value. This value won't. So because 1 and 7 are, the complements of each other, so they are the same thing. And then, did everyone get this first observation? If you didn't, please let me know. So as the size of the window increases, the total count also total count decreases later. So I guess everyone got observation 1. If you didn't, again, please let me know. The first and the last values don't increase after some number of iterations. So notice, let me erase everything. So the first and the last values, so for example, A doesn't increase after 1 iteration. B doesn't increase after 2 iterations, C doesn't increase after 3, and D doesn't increase after 4. So notice this is happening because the index of the element in the window, starting window, so the maximum will always be equal to k. So at max, the number of times value will be repeated is equal to k, because a window will stay on the same element for at most k times. After k times, it moves out of the range of the value. So say this was some window, then it will have been this, then this, then this, and so on. And then at one point, it has to leave the element. So the number of times it repeats before it leaves the element is k times. So the maximum will be at most k. So then the other value is defined by where its index is. So for example, since A is at the first index, the window will be glossing over it. So it won't be, it will just take A once. After the first window, it will just move on to the second window. The second window will not contain A. And same for B. For B, it will move after two times. So the value is defined also by the index. So for example, the first index is only 1, the second index is only 2, and third index is only 3, and so on. Also, this is the same for the last value. For example, G. So G will have, so it will come till this index and then it will finish at G. So G is taken only once, and F is taken only twice. So for example, it will be something like this. Then it will come into F, then it will come into G, and then it will stop. So F is taken at most 2 times. So the value is directly correlated to the index. So if it's the number of elements is distance from the value. So can you show the problem again? Sure. So did you guys get observation 2? If you didn't, please let me know. Okay, I guess if you didn't, please react to the confused emoji. Okay, so now if we take the count now, so as you can see, the value the 4 is taken once, and then 3 is taken like this is like a square. So these are squares, so every element in this square is a 2, and so on. But as we said, we don't need these values. We don't need k equal to 1 to k equal to 3. We just need these. So now what we can do is very simple. So we can just say that we are taking prefix of I. So for example, you can take prefix of I, and then we can just take the opposite of the prefix. So we can take prefix of n minus I. So prefix of n minus I is, in this case, say we are starting at 1. So we are going to be taking s equal to some value. So s equal to the prefix of n. So prefix of n minus 1. So prefix of n minus 1 is the total sum of the array. So if you remember how prefix sum works, it is the sum of the first I elements. So the prefix sum of n minus 1 will be the total sum of the array, and we are going to be keeping that as the current value. And then we are going to be adding the values from b to f. So you can just multiply this value. So originally it will be like this, and then b will be multiplied by 2, and every other value till f will be multiplied by 2, then it will be multiplied by 3, and so on. So this is good enough, but you can use prefix sums. You can use prefix sums to make this a bit more easier. So for example, we can take, so this is index 0, 1, 2, 3, 4 and 5. So this is index 5, and then we are going to be removing prefix of 5. We need the sum from b to f. So b is equal to index 2. So prefix of 5 minus prefix of 1 minus 1. So as I said, L equal to, in this case, L equal to 5. L equal to 1 and R equal to 5. So we want the sum of elements from b to f. So now prefix of 5 minus prefix of L minus 1 is 0. So prefix of L minus 1 is 0. So this is a is equal to 1. So we are going to be removing a from the total. So we are going to be adding, basically we are going to be adding this value again. So we are going to be adding this value to sum. So sum equal to sum plus prefix of 5 minus prefix of 0. So you can also do this again. So for example, s equal to s plus prefix of 4 minus prefix of 1, and so on. So this will give you the next element. So originally we were adding this, so it gave it this, and then we are going to be next adding this value, this part, so the middle 3. So we are going to be adding the middle 3, and then we are going to be adding the middle 1. So we are going to be adding that. Could you please explain the prefix part again? Sure. So let me erase everything. And the prefix part is that you have the sum of the elements. So you have sum of prefix of 0 equal to a0. So a0 is array of 0 is equal to a, and then a plus b, and then a plus b plus c, and so on. And you want to take, so as you can see, the values are increasing one by one. So it increases from 2, and then goes to 3, and then goes to 4. So basically, so this is like a pyramid of sorts. So you can just say, you can call this a pyramid. And we take the original sum. So basically, the minimum value, the value will always be at least the sum, total sum. So if we set k equal to, if we set k equal to the entire array, so that's the length of the entire array, then it will be the sum of the entire array. So prefix of n minus 1 is equal to sum of all the elements, right? So prefix of n minus 1 equal to sum of all the elements. So now we are going to be initializing s equal to prefix of n minus 1, or the sum of all elements, and then we are going to move the pyramid. So we are going to move the pyramid by adding s equal to s plus prefix of, so this is index 5, so f as an index of 5, minus, so we are basically saying L equal to b, so the index of b, so index of b is 1, and R equal to the index of the last element, so index of f. So as we saw, let me go move to the prefix sum part. So as we saw, prefix of r minus prefix of l minus 1 gives you the sum from l to r. So you remember that hopefully, and we are going to use that to our advantage. When will the class end? I actually said that I'll extend it by 30 minutes. So I extend it by 30 minutes, so it ends at 7:30. So s equal to s plus p of 5 minus p of 1 minus 1. So 1 is the index of 1 is equal to L, and L minus 1 is 0. So this is what we are going to add. So this will give you the following. So this will give you the next pyramid of value. So did you get it, Sumant? Okay, I guess if you didn't get it, please let me know. So we'll next add s plus p of 4 minus p of 1, and then we'll do the same for 3 and 2, and then it will end. If you didn't understand, please let me know. Okay, one person didn't get it. So if you could explain which part you didn't get. Didn't you get the prefix sum part or the observation part? Oh, okay. And then we got the solution right now. So the second observation is the first and last values don't increase after some number of iterations. This problem will take a lot of time without programming. That is true, but ZIO is the ZIO is a contest that doesn't use programming. So it's an exam which doesn't use programming, so you have to get used to it. So given distinct, this is the ZIO problem. So we are going to be discussing the ZIO problem so that we can, get the live experience of how an ZIO problem would be. Given distinct scores of two different exams, select cutoff marks x and y. So we are going to select cutoff marks for x and y for the exam such that exactly k people will pass from both the exams combined. So actually this is ZIO 2020 problem 3, and I have simplified the problem statement. This problem statement is a bit more complicated than this, but it's the same thing. So this is the same thing except I removed the unnecessary parts. So if we select, for example, if we have an array like scores like 1, 2, 3, and then 1, 2, 3 again, then if you select the cutoff score x equal to 2 and y equal to 1, so this will be 2 plus 3. So the total number of people passing will be 5. So this is actually where this was actually x equal to x is the cutoff for ZCO and ZIO. So that was how it was defined in the problem. And k people will go to INOI. So including both from both the exams. So 5 people. So the 5 people will in total will pass. You want to we make it such that exactly k people will pass the exam. So you want to select two cutoff marks such that exactly k people will pass both the exams combined. So then you want to minimize x minus y. So to make the contest seem equally hard, you want to minimize the absolute difference. So you want to minimize the difference of the cutoff. If there are multiple answers, maximize x plus y. So if, for example, if you can select 3, 3 such that the 3, 4 such that the answer will be the number of people who pass will be equal to k. So number of people will be passed equal to k after cutoff, and there is 4, 4 for example. This will also pass k people. In this case, you take 4, 4 because this has the greater sum. So for the scores, you are given the scores. What would be the x plus y? So you want to maximize x plus y, but before that you want to minimize x minus y. Absolute value of x minus y. This is the first priority, and if there are multiple answers, you want this is the second priority. So always they should exactly be k people. So how would you solve this problem? So you guys can send your answer in the comments. You can take the score from both the exams into one list. Actually, that's not possible. You cannot take the score of the exams into one list because it will, you won't know which people will pass. So, and you won't know which values for ZCO and which values for ZIO, so you won't be able to minimize this value. Sort both arrays and brute force with a pointer moving in one array. Yes, this is exactly the answer, and I'm going to explain this in simpler terms right now. First, sort the given scores in reverse is the process. So if you sort the given scores, first reverse them, and then assume you select two students, 0 students from exam 1 and k students from exam 2. So basically we are just going to be starting with a graph like this. So 0 students passed from ZCO and k students passed from ZIO. Then it will be 1 and then it will be k minus 1. So we are going to be doing that. So we are going to just keep doing that for all values. And then increase the number of students selected from exam 1 and decrease the number of students selected from exam 2. So basically make it 1 k minus 1 and 2 k minus 2 and so on till k and 0. So you are going to be repeating that. And then, if you selected k students from a group, then the cutoff has to lie in the range scores of x, comma scores of x minus 1. Again, remember that we are using zero-based indexing. So we'll take this example array. So let's first sort it. And then if we take the cutoff, let's say we want 0 people to pass from this first array. So then we have a value from infinity. So if we set the score as infinity, nobody will pass. And it has to be less than or equal to infinity, and it has to be greater than 60. So x has to be greater than 60. So the reason is, if we select x equal to 60, then one person will pass, right? So one person will pass, and we don't want that. We are assuming that 0 people are passing from the first array, and then we just know that the cutoff lays in the range infinity to 61. So now, say we want exactly one person to pass. We can say that 60. It has to be less than or equal to 60. If it's greater than 60, then it means that 0 people will pass. So we don't want that. So it has to be less than or equal to 60, and it has to be greater than 31. So it has to be greater than 31. If it's equal to 31, then 2 people will pass. So we know that the cutoff has to lie. So if you selected x students from a group, then the cutoff has to lie in the range scores of x, comma scores of x minus 1. So if you selected 0 people, then 60 index of 60 is 0. So it has to lie in the range the scores of x is equal to 60. And notice that we have a curly, we don't have a square bracket here. We have parentheses, and that means that we are not including scores of x. So this is greater. Scores of x is greater than, the x has to be greater than scores of x. And then if we have a square bracket, then it can be equal to, so less than or equal to. So now we'll take that, and if the index is less than 0, for example, scores of x minus 1 is equal to infinity. So the reason is 0 minus 1 is minus 1, and we don't have any other values, so we are just going to assume that it's infinity, since we can select any value. If index is greater than or equal to n, for example, if you want k people to pass, if you want exactly all k people to pass from this array, then you just do scores of k. So scores of k will be greater than the index. So the indexes are 0, 1, 2, 3, 4 and 5. And if you want to select 6 people, then scores of x will be out of the range. So scores of 6 will be out of the range. So in that case, in case the index is greater than or equal to n, we assume it's negative infinity. So this we assume that it's negative infinity. So if you set the cutoff as negative infinity, then everyone will pass. Everyone will definitely pass. So you can also set it to 0 because no value will be greater than 0, no value will be less than 0, but we are going to assume it as in negative infinity. So where number n is the number of stores. For each x, take the maximum cutoff such that the absolute value is minimized. So for each x, we'll take this example again. Take the maximum cutoff such that the absolute value is minimized. So for example, so if we select 0 people from exam 1, then 6 people from exam 2, cutoff 1 has to lie in the range 60, infinity. We talked about that. 60, infinity. And cutoff 2 has to lie in the range 1, 2. The reason is we want exactly k people to pass, and there are 7 elements, while the number of people you want to pass is 6 people. So since there are 7 elements, we are just going to assume this as greater than 1. So if it's equal to 1, then 7 people will pass. We want exactly k people. So we are going to set it as 1, greater than 1, and then x is less than or equal to 2. So we will say this as 1. Y is less than or equal to 2. 2 is the second value. So it has to lie in the range 1, 2. So the most optimal x comma y is 61, 2. Note that infinity comma negative infinity comma 2 is also a valid answer, but the problem is it doesn't minimize the absolute difference. So infinity minus 2 is also infinity, which doesn't minimize the value. So it can also be 62, 63 or any other value, but greater than 61. But the problem is it won't minimize the value. So the most optimal x comma y is equal to 61, 2. How can we have a closed basis on infinity? You can't, but I'm just, this is for problem's sake. So yeah, x equal to zio and y equal to zco, yes. So now if we select one person from exam 1 and 5 people from exam 2. So if we select one person from exam 1, then it has to be greater than 31 and less than or equal to 60. And the second value has to be, so since we were having 1 and 2, it will be greater than 2 and y is less than or equal to 8. So if we select any value from 8 to 3, then it will be selecting 5 people. So we want 5 people to pass from exam 2. So cutoff 1 has to lie in the range 31, 60 and cutoff 2 has to lie in the range 2, 8. So the maximum is 32, 8. So since this is greater, so we have to select 32, and since we want to minimize it, we are selecting 8. We can also select 3 for example, but this won't minimize the value. So select 2 people from exam 1 and 4 people from exam 2. So this will be 29 to 31. So 30, 31 are valid cutoffs. And then select 4 people from exam 2. So if you want to select 4 people, then it will be in the range 8 to 9. So it is greater than 8 and less than or equal to 9, which is exactly one value. So let me just erase everything. And it has to lie in the range 29, 31 and 8, 9. So the maximum will be 30, 9. So the maximum is 30. So if we take this value, so it will be 30. Which will make exactly 2 people, actually it will make exactly 2 people pass if we select 30. And then if we select x equal to 30 and y equal to 9, then the difference is 21. So this is the minimum value you can get by selecting 2 people from exam 1 and 4 people from exam 2. And then select 3 people from exam 1 and 3 people from exam 2. So this will be 3 people from exam 1 means that it has to lie in the range 23 is greater than 23 and then it's less than or equal to 29. So less than or equal to 29. And the next value we want to select 3 people from this too. So it has to be greater than 9 and less than or equal to 18. So then we got that. So the most optimal here is 24, 18, which is only 6. And then select 4 people from exam 1, which would be 22 greater than 22 and less than or equal to 23, which should be one, which has only one value possible, which is 23, and then 35 comma 22. So you can select from 18 to 22. So if you select 22 comma 23, then the final result is minimized. So the final result is equal to 1. You can't go any lower than that. It will always be equal to 1. So this is the answer actually. So the minimum value equal to 1. So you can repeat this for the next two values for practice if you want, but this is the answer. 23 comma 22 is the answer, which is equal to, the total sum is equal to 45. So did everyone get that? So this is an ZIO problem. We just solved an ZIO problem. So this is the first subtask. This is actually the first subtask of the problem. So we just solved a single subtask, and then you can also repeat the same thing for for the second subtask for practice sake. And does anyone have any questions? This is actually the last session in my, and this is my last session in this course. So if you have any feedback, do let me know. So this is my last session. So if you want, if you have any questions, ask me if you want. So, and you can contact me on contact me with Steve hashtag 5123. So, and you can PM me. It's no problem. So you can PM me, and you can provide your feedback. So I would appreciate it if you provide feedback. I could improve in the future. And yeah. So again, this is my last session. If you have any questions, please do let me know. Okay, so shall we end the session? All the best for Israel, you guys, and bye. See you later.